Hello everyone, welcome to my channel CIC Topper Classes. Today we are going to discuss Class 9 Triangles Exercise 10.2 question number 1 to 10 of M.L.Aggarwal Class 9 Mathematics. So let us start solving this exercise here in this video. If you like this video, please like, share and subscribe my channel.
Now let us solve exercise 10.2 here, in which I am going to use 5 rule of congruency to prove two triangles congruent. So firstly it is SSS, second is this is side rule of congruency, SAS side angle, fourth is angle side congruency, fifth is right angle hypotenuse side congruency rule. So these are the 5 congruency rules to prove two triangles equal. So let us solve here the first question in this exercise. So the first question here says that in triangle ABC and PQR, angle A is equal to angle Q and angle B is equal to angle R. So this is angle A is equal to angle Q, angle B is equal to angle R from here. So we have to prove that, find that which side of triangle PQR, means this triangle PQR should be equal to side AB of triangle ABC, so that the two triangles are congruent. Simply I have made the triangle of PQR in the form of QRP, so that we can just make it CPCT like. So here it is AB. We have to find which side should be equal to PQR triangle, so that the triangles are congruent. To prove that this is the included side between the two angles which we have taken. So from here on comparing AB is equal to QR and angle Q here and angle R here, which is equal to angle A and angle B respectively. So this is the included side here. Simply we can write that from here AB is equal to QR, and we have to find the give reason. So here we have S angle side angle congruency. So ASA rule of congruency. Hence we have side AB equal to QR, because this is the included side between angle. Now, let us solve the second question here. It is given that in triangles ABC and triangle PQR, angle A is equal to angle Q and angle B is equal to angle R. So, which side of PQR should be equal to side BC of angle ABC, a triangle ABC, so that the two triangles are congruent? Give reason for your answer. So firstly, we can make it like this also. We can write here Q and here triangle QRP we can also make, because to compare it more smoothly than this triangle. So firstly, we can make it because it is congruent only. So angle A is equal to angle Q here and angle B is equal to angle R here. So which side of BC of triangle ABC will be equal to this triangle? So this is RP on comparing the same side and same angle. So we can simply write BC should be equal to RP, because here Q and R are equal. So we have here angle side rule of congruency. And here this is the angle and this is the side. So angle side rule of congruency we have used here. Now the third question here says that if two angles and a side of one triangle are equal to two angles and a side of another triangle, then the two triangles must be congruent. Is the statement true? Why? So simply we have here, if the two angles are same, so the corresponding side should be also same, to prove that the both triangles are congruent. So the reason here is it is not true, because the corresponding side should be equal. Side of the triangle should be equal. Now let us solve the fourth question. It is given that in the adjoining figure, AD means AD is median of triangle ABC, and BM and CN are perpendicular drawn from B and C respectively. So on AD and uh, AD produced means BN. Prove that BM is equal to CN here. Means BM is equal to CN. So here we will take these two triangles as BMD and CND to prove that BM is equal to CN. Means BM is equal to CN here. So the given information here in this question is that AD is medium, means BM BD is equal to DC here. This is given because AD is median. Now here we have this as right angle triangle. So this angle BMD and CND are equal because they are perpendicular. So BMD and angle CND are equal to 90 degree, as this is equal. And perpendicular. Now we can simply write here the second thing as, because it is given in the question that BMD means here this angle, because it is vertically opposite angle. So this is angle BDM and angle CDN are equal because they are vertically opposite angle. So these are vertically opposite angle. So this is the thing here. Simply we can prove now triangle BMD is equal to triangle CND here. So this will be triangle BMD congruent to triangle CND by angle side congruency. So this is the congruency which is used in this question. Now from this congruency we can simply prove that in this triangle BM is equal to CN as CPCP. So BM is equal to CN because this is CPCP here. Now let us solve the fifth question here. It is given in this question. In the adjoining figure, BM means this BM and DN are perpendicular to the line segment AC. So if BM is equal to DN here, then prove that AC bisects BD. So firstly we can prove here that BEM is equal to DEN, so that simply we can get that AC bisects BD here. So let us solve here. Here to prove that AC bisects BD, we can simply write that um, BE equal to DE. This we have to prove here. So to prove this, we can simply write that these two triangles are congruent. We have to prove. So from here we have perpendicular and this is also perpendicular. So angle DNE is equal to angle BME, which is equal to 90 degree. So this is perpendicular, hence it is given here also. The second thing which is here, these are the vertical opposite angle. So from here DEM equal to angle BEM, because these are vertically opposite angle. The third thing here is Given it is BM is equal to DN. So this is given here. Now from here we have two angles equal, this and this side equal. So simply we can write here AAS rule of congruency. So we can prove that triangle DEN is congruent to triangle BME by angle side rule of congruency. So this is the thing. And from CPCT now we can prove that DE is equal to DE here. And if we prove that DE is equal to DE, and from here hence by CPCT we got it as AC bisects BD. So this is the thing we have to prove here. Let us solve the sixth question here, which is in the adjoining figure, L and M are two parallel lines intersected by another pair of parallel lines P and Q, so that triangle ABC is equal to triangle CDA. So because this all is uh, parallel lines, so to prove this, the triangle ABC is congruent to triangle CDA, we have as AD equal to BC. So from here AC is common in this triangles. So AC is equal to AC because it is common in both the triangles. And here we have alternate angles. So this is equal to this and this is equal to this because these are alternate angles. So simply we can write angle BAC is equal to angle ACD because it is alternate angles. Now we have angle DAC, means this DAC is equal to angle ACB. So this is also alternate angles. So simply we can write it as that angle side angle congruency is equal. Means here ABC is congruent to angle CDA by angle side angle rule of congruency. So this we have to prove here in this question. Let us solve the seventh question here, in which in the adjoining figure two lines AB and CD intersect each other at the point O such that BC is parallel to DA and BC is equal to DA. Here the given information is so that O is the midpoint of both the line segments AB and CD. So we have to prove that OA is equal to OB and OC is equal to OD. From where we can get that O is the midpoint of both the line segments. So we have to prove that OA is equal to OB and OC is equal to OD. So this we have to prove. To proving this, firstly the information which is given to us here in this question is that BC is parallel to DA and here BC is equal to DA also. And it intersects at the point O. Simply we can write that angle from here we have alternate angles also. This is given to us because these two lines are parallel. We can write angle BCD and angle BCO also we can write is equal to angle uh, BCO and here ODA. So ODA. So these are alternate angles. Again we have here angle CBO is equal to angle OAD. Angle CBO equal to angle OAD. This is also alternate angles only. So from this we have angle side angle congruency. So triangle AOD is congruent to triangle COB, and which is from angle side angle rule of congruency. From there we can prove that AO is equal to OB and CO is equal to OD. And if these are equal, we can write that the midpoint of both the lines, midpoint of both the line segment is equal to is O only. Both the line segment of AB and CD is O here. So this is the thing which we have to prove here in this question. Now let us solve the eighth question here in this exercise. So in that joining figure, angle BCD means angle BCD is equal to angle ADC, means BCD is equal to angle ADC here. So this is the given information. Now angle BCA is equal to angle ADB. So here we have to prove that triangle ACD is equal to triangle BDC. So simply we can write here firstly the given information as BCD is equal to angle ADC. So simply this is given to us here. Now we have BCD is equal to ADC. ADC. So simply again we have the given information as BCA, means BCA is equal to angle ADB. As we have BCD is equal to ADC, so simply we can add if so BCA plus BCD equal to ADB plus ADC. So this will be BCA plus BCD and here ADB plus ADC. So we can write it as ACD, angle ACD is equal to angle BDC. So this we have proved here. And now the third is in the triangle CD is common here. So we have three things here common. Now we can simply write that it is angle side congruency. Means here we have these angles and this is the angle which we have. So from here we can simply write that BCD is also equal. So it is uh, angle side congruency here. From here we have triangle ACD is congruent to triangle BDC. So simply this we have to prove in the first part. Now the second part here is BC is equal to AD. So we can simply write that BC is equal to AD, which is here CPCT. Now the third part here is angle A is equal to angle B. Means these two angles are equal. So this is also CPCT here because this triangles are congruent by angle side congruency. So this is here angle side angle congruency. Let us solve the ninth question here. In the joining figure, ABC given to us is ABC equal to ACB and D and E are points on the side AC and AB respectively such that BE is equal to DC. Then we have to prove that triangle EBC is congruent to triangle DCB. So for proving this, the given information to is BE is equal to CD and CB is common here in these two triangles, which we have to prove congruent. This one and this one. Simply we can write these two things. Now we have from the given information as ABC is equal to angle ACB. So here we have, from this information we have DBC is equal to DBC is equal to angle ECB. So this is equal. From this given information we can write simply. From here we have as two things congruent. So these this we can prove as side here, this one side angle side congruency. So this is triangle EBC is congruent to triangle DCB by SAS rule of congruency. So this is the SAS rule of congruency here. Here this is the first part. Now the second part is triangle OEB is congruent to triangle ODC. So to prove that triangle OEB is congruent to triangle ODC, we can simply subtract from this congruency triangle EBC congruent to triangle DCB. This is the triangle sign. So this is DCB. So subtracting, because this is also equal here from EOB. So here simply we can write it as OBC. We will subtract because it is common from both these in this triangle it is common OBC. So we can subtracting OBC from both sides. We can write it as triangle OEB is congruent to triangle ODC. So hence proved from here. Now the third part here in this question is, which we have to prove, is OB is equal to OC. So from this congruency we can find that OB is equal to OC from CPCT here. Now let us solve the 10th question here. ABC is an isosceles triangle with AB is equal to AC and draw AP perpendicular to BC. This is perpendicular 90 degree to show that angle B is equal to angle C. Simply we can write the given information firstly. AB is equal to AC here. This is given. Now we have AP perpendicular to BC. So similarly we can write it as 90 degrees. So it will be APB. Angle APB is equal to angle APC. So this is equal to 90 degree here in both the cases. Now we have AP as common in this. AP is equal to AP means common in both the triangles. Hence angle from right angle hypotenuse side congruency, we can simply say that angle triangle ABP and angle A triangle ACP is equal. So angle, from here we have angle ABP is congruent to triangle ACP by RHS rule of congruency. From here we know that this is the RHS rule, means here it is right angle and now this is hypotenuse and this is side congruency. So we can simply write here as by RHS rule of congruency. So we have to prove that angle B is equal to angle C. From CPCT we can simply prove that angle B is equal to angle C, which we have to prove in this question here.
Thank you for watching my video. If you like this video, please like, share and subscribe my channel.